Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. Count good nodes in a binary tree. So basically in this question we are given with a node, and that node is the root node of that particular tree, in which we are required to traverse the whole tree and figure out with the good nodes. And as per the definition given in this question, a good node is basically let us check the question explanation itself, that we are given with a binary tree root. A node x in the tree is named as good if in the path from the root x, that from root 2x, there are no nodes which have a value greater than x. So basically if any particular node is there and we are traversing from root towards that node, then in the path if there are no nodes greater than that particular x, then that node is basically counted as the good node. So what they exactly want to say is that if 1, 2, 3 are there, then all of these are the good nodes. Basically they are in increasing order. But if it is something like this, say it is 3 and here it comes out to be 1, then in this criteria only this is the good node, but this is not the good node, because you can clearly see that this becomes into a decreasing order sequence, right? So that's why all these are the good nodes, but this is not the good node. So at the end we are required to return the number of good nodes in the binary tree. So that's the thing which we are required to do here. Now comes the part that how we will be doing this question. So then we are given with a tree question. Then either we do BFS, DFS, right? But here that BFS is basically represented by the level order traversal, and DFS is basically represented by either a pre-order traversal, either in-order traversal or post-order traversal. So that's the scenario. But pre-order, post-order or in-order, everyone will give us the same answer itself, only the traversal mechanism will change. So now let us go in this question. So in this question basically I will be going ahead with the DFS approach, and I will be going ahead with the pre-order traversal. So that's the thing I will be doing here. First I'll go for the root, and then for the left child, and then for the right child. So that's how I will be doing the pre-order traversal. So how the things would be. So even in any sort of traversal, because DFS I will be doing by recursive approach, so surely we would be required with a base case, and then we will be required to check for the option, as it is a tree, so we are having only two options, and the algorithm which will be required here, and that algorithm would be based on this particular thing only, that is it should be in increasing order, and the last condition would be the recurrence relation which will be formed out of these options. For all trees almost for all trees the recurrence relation remains the same. Only part which is there is the algorithm which we will be designing in between on the basis of the condition given to us, only that will modify the thing, else everything will remain the same. So now comes the part that before going for the base case, let's check for the options and even for the algorithm. So here we are having option, either we can go to left or we can go to the right. So that's why we are having two options. Now in these two options, what we are required to check. So as we will be going ahead with the recurrence, as we will be going ahead with pre-order traversal, right? So what I will be doing is, I will be first checking that if my present node which is there, so my root value which is there, if that particular is basically root would be the one which will be coming from above, right? And the one is one of them would be previous node which I will be having. So if root value is basically greater than my previous value, then I will be surely increasing my count of good nodes. That thing I will be doing. I will be doing in the first hand itself, as I am doing pre-order traversal, and then I will be checking for my left node, and in this left node I will be means whatever roots left is there, I will be going ahead with the same, because now we are required to check for a left subtree, and then I will be also checking side by side only about my this particular means previous maximum node. But now here I'm also required to update whatsoever is maximum of previous or my root value. That is also the thing which I will be doing so, right? So that thing only I will be passing here, and then I will be go ahead for my right node. That's the thing I will be doing, because in the left tree when I will be going ahead, surely when I move back, then I need to make call for my left right subtree also. So that's why I will be doing this thing also. So that's the thing which I will be going ahead. And then next comes the part, and because now we are done with our, this is basically a recurrence relation. This is the algorithm in between stuff which we are required to do to complete this question. And then at the end comes out to be the return condition. So at the end we are required to return the root which we would be having at that particular point of time. So these all stuffs are there. Now comes the part for the base condition. So when we want to stop or when we want to return, so basically if our root doesn't exist, basically if our root is equal to null, means at some point it will reach null, right? So that's why here we will be directly returning, either we will return the null, that we need to figure out that what is the, that what we say, return statement of the function. According to that only we'll check either when root is equal to null, so either we will be returning null or we will be returning 0. So either of these things we can return. These things are basically dependent on the function return type which we are taking. So when we will be coding, then I'll show you that what it is there. But the main intention of doing this question is something like this only, means this is the overview that how we will be doing this question. Because the thing is that we want the increasing order in our traversal, and in that increasing order, whatsoever nodes we are encountering, that we will be storing. But as we are just required to return the count, so that's why rather than storing those nodes, we will be checking out that what is the count of those good nodes, and after that we will be returning that count. So that's the thing which we will be doing here. So now comes the part, the coding part of this question. So let me show you that how we are required to code it. So basically for this particular question, yeah, it is visible. Now the thing is that this is the thing which was given to us, and we are required to return int, basically the count of the nodes, right? So here I am checking, because the return type of our function is basically integer, so that's why we are returning 0 here. So that was the thing I was saying at that particular point of time. So if the root doesn't exist, basically root is equal to null, because there could be a case when here we are just given with this, right? So at that moment also we are required to return. So that's why we are returning 0, because that simply represents that there is no node there. So that's why we will be returning 0. So now then we are required to DFS. So for DFS, here I have taken the data type as int itself, but as we were required with 2 parameters, so that's why I have created a new function where root would be passed, which will be acting as the present node and its value. That would be the thing. So now comes the part here, that DFS, then our present node and the maximum value. So basically the root value which we are passing, if there is a case that there is only one node, that is the root value itself, so that value will itself be the maximum value, right? Or if there is a case, see, you can see that if only one is present in our root, right? So we can take it as maximum value also, rather than assigning any other maximum value. Or the other way around is that if we are given with just 2 nodes, 1 and 2, right? So from which we will be comparing? We will comparing by this only, right? Means this one. If this is basically the smaller, and then it comes out to be this, as we require the increasing order, right? So then also we will be comparing by this only. So that's why passing the root value itself is the best criteria here, I can say. and then the base case as we were discussing, and then int good node equals to 0. At the starting we are just initializing the good node count, and here we are checking that if root value means the value which is coming up, if it is greater than or it is equal to the maximum value, then in that criteria we will be updating our maximum value and making our good node increment the same. That's the thing which we are doing, and at the end we are returning good nodes, that is the count which is there, and adding up the left and the right count which we will be getting from these functions. So that's the thing which we are required to go ahead. So basically this is a left call, this is a right call, and adding up simply represent that whatever we will be getting from this left call and right call, and even this good node, that we are going to return because we are having the int return type. So integer values are required to be returned. So this is the thing which we are required to do in this question. Now comes the part for the time complexity and space complexity. So basically the time complexity for this whole question is, you can clearly see that we are going this way and this way. Basically we are traversing as per the height of this tree. But there could be a scenario when the tree is basically a skew tree. So in that criteria, this particular height of tree becomes equals to n, that is number of nodes which are there. So that's why the time complexity is basically order of n, and even the same logic applies to the space complexity, because in the DFS we will be using a recursive stack, and the recursive stack would be having all the nodes to the level of height, and in the worst case scenario that height could be converted into n, right? So that's why the space complexity will also be as order of n. So this was all for this particular question. If you have any doubt, you could comment that down, and if you like the explanation, please do like and subscribe and share my channel. Thank you.